Welcome to math classes. Let's see some JEE PYQs of integration. Mainly this is all definite integration problems. Okay, this is part 4 of the video. So you can check the other videos in my playlist, which will be I'll mention in the comment section. In this video, mainly we'll learn two new concepts. One is the Newton-Leibniz theorem, okay, which is very useful when you do differentiation of a integration. This is one very useful thing. Okay, and second one is beta function. Okay, so let's see when we come to those. Okay, yeah, first one is limit of x tends to pi by 2, integration of x cube to pi by 2 cube, sine of 2 t to the power of 1 by 3 plus cos of t to the power of 1 by 3 dt divided by x minus pi by 2 square is equal to. Okay, so we need to find out the limit first. Okay, so if I apply this limit, okay, x equal to pi by 2, if I apply the numerator section, if you see, okay, numerator integration from pi by 2 cube to pi by 2 cube. Okay, upper limit and lower limit are same, so integration will become 0. Correct. And denominator also, if I apply x equal to pi by 2 minus pi by 2 0. So this is in the form of 0 by 0. In limits, we know that if you get in a form of 0 by 0, you can you should apply L'Hospital rule. That is basically you differentiate numerator and denominator once. Correct. So we need to go differentiation of this integration, right? So this is where this Newton-Leibniz theorem is very important. Okay, so what it states is, in a simple term, differentiation of integration from a to x f of t dt with respect to dx is f of x. Okay, how this has come? Okay, integration and differentiation gets cancelled, we know. Okay, but only thing is we need to apply the limits. Okay, so limits you will apply x and a, so this will become x of f of x minus f of a. Okay, but since we differentiated, the constant term goes to becomes 0 basically, so f of x is left. Okay, so you ignore the constant, and if it is, let's say if it is reverse from x to a, then it will become minus f of x in that case. Okay, so hope you understand the simple Newton-Leibniz theorem. But in this case, okay, in this case you have not simple x, but you have a function of x. X cube is there. Correct, x cube is there. So in that case, what we have to do is, same Leibniz theorem states, differentiation of integration from g of x to h of x f of t dt dx is, okay, same thing you will do. You apply the upper limit on f, that is f h of x, and differentiation of h of x, that is h dash x, minus lower limit f of g of x, differentiation of g of x, g dash x. Okay, so this is what very important theorem. Okay, useful for the definite integrals especially. Okay, so let's apply this. This is already we checked it is in 0 by 0 form, so we need differentiation, right? So when you differentiate the numerator, okay, differentiate the numerator, this is here. Okay, I need to just apply the limits, right, and differentiation. Okay, so this will become upper limit if I apply sine 2 pi by 2. Correct, because this is pi by 2 cube, so t is pi by 2 cube, so it will become pi by 2. 2 times pi by 2 into differentiation of pi by 2 whole cube, which is 0, because that is a constant. Okay, plus cos also, differentiation of pi by 2 cube will become 0. So if I apply limits on this one, this is 0 anyway, minus lower limit I am applying now. Okay, this will become sine 2x into differentiation of x cube, which is 3x square, plus cos x and differentiation of x cube, which is 3x square, which is 3x square times sine 2x plus cos x. So this is as simple as that. Now you write the limit. So given limit is nothing but limit x tends to pi by 2 minus 3x square. Okay, because this is minus, right? This is minus 3x square times sine 2x plus cos x divided by 2 times pi x minus pi by 2. If you apply x equal to pi by 2, this also becomes 0 by 0. So you apply L'Hospital rule again, okay, and differentiate numerator and denominator. Okay, so what it will become is, okay, minus I have taken out. Okay, so this will become 3x square sine 2x. That is nothing but, if I differentiate, 6x sine 2x plus 6x square cos 2x. Okay, then 3x square cos x, it will become 6x cos x minus 3x square sin x divided by differentiation of this one is 2. Okay, now you apply pi by 2, you will get your value, which is nothing but you can simplify it yourself. 9 pi square by 4 is what the answer is. Okay, hope you understand this important Newton-Leibniz theorem. This is very useful for the definite integrals. Okay. Next. Yeah, integration from alpha to log 4 to the base e, basically ln. Okay, 1 by square root of ex minus 1 dx equal to pi by 6. This is given. Okay, then e alpha and e minus alpha are roots of the equation. Basically, you find out alpha, and what is e alpha and e minus alpha you find out, and then quadratic equation with those roots. Okay, so let's go one by one. This is the given integration which we need to solve, and this is nothing but pi by 6 value is. Okay, so let's take e to the power of x minus 1 as t square because it is under square root, right? That's easy. Then e to the power of x dx is 2t dt. Sorry, dt is missing here. 2t dt. Okay, or dx equal to 2t by e to the power of x, which is nothing but 1 plus t square dt. Okay, so now if I substitute all the values, integration is nothing but integration from alpha to log 4, 2 by 1 plus t square dt, which is nothing but 2 times tan inverse of t. Okay, I did not change the limits because this is a simple integration. I can get it back into x terms. So 2 times tan inverse of square root of ex minus 1. Okay, now you apply the limits, it will become 2 times tan inverse of square root of 3 minus tan inverse of square root of ex minus 1. Okay, sorry, e to the power of alpha minus 1, which is equal to pi by 6. Okay, now 2 goes to other side, it will become pi by 12. Okay, and tan inverse of square root of 3 is nothing but pi by 3. So minus tan inverse of square root of e to the power of alpha minus 1, which is equal to pi by 12. Okay, solve it. Just basically tan inverse value is equal to pi by 4, which means tan inverse when it is pi by 4, when this square root of e to the power of alpha minus 1 is 1, correct? Which means e to the power of alpha is 2. So all I need is e to the power of alpha, which is 2, and e to the power of minus alpha, which is 1 by 2. So quadratic equation with 2 and 1 by 2 as roots. Sorry, this is not 21. 2 and 1 by 2 as roots. Okay, so that is nothing but x minus 2 into x minus half, which is equal to 0. Okay, if you simplify, you'll get 2x square minus 5x plus 2 equal to 0. This is the quadratic equation which is required. Next. You can also try solving this by taking square root of e to the power of x minus 1 equal to tan theta. Okay, if you are good in trigonometric equations, you just see this one, e to the power of x minus 1, if you take it as tan theta. Okay, what happens is differentiate, you will get e to the power of x dx, which is nothing but tan theta or tan square theta, basically you can take. Okay, so it will become, you will get tan and secant in terms of tan and secant square. Okay, that is easy to solve. You can try yourself this one. Next. Okay, the value of integration from minus 1 to 2 of log of x plus square root of x square plus 1 dx is equal to. Okay, so simple way of, I mean easy way of solving this one is if you don't remember any other formula. Okay, this is nothing but sine inverse of sine hyper inverse basically. Okay, but if you don't remember that, whenever you see logarithms, you solve using a product rule. Okay, that is the easy way. So f of x equal to log of this one. This I am taking as my first function because in I late, okay, I late, L is first, logarithm is first. Okay, algebra is later. Okay, so g of x equal to 1. Okay, so I is this value. If I integrate, this integration is nothing but log of this value into integration of 1, which is x, minus integration from minus 1 to 2 of differentiation of this one is nothing but 1 by x plus square root of x square plus 1. Then integration of this one is nothing but 1 plus 2x by 2 times square root of x square plus 1. And then integration of 1 is x, which is here. Okay, we should apply limits to this one. Okay, if I apply limits to this first part, this will become 2 times log of 2 plus square root of 5 plus log of square root of 2 minus 1, because I'm applying 2 and minus 1. Minus, I'm calling this as I2. I'll solve it now. Okay, so my I2 is this value. Okay, and if I simplify, this is very simple. This is integration from minus 1 to 2 of x by square root of x square plus 1 dx. Okay, now you consider x square plus 1 as t, and you can solve it easily. You will get half of integration of 1 by square root of t dt, right? That is nothing but I2 is half of 2 times square root of x square plus 1. If I apply limits minus 1 to 2, this will become square root of 5 minus square root of 2. Okay, now my integration is simple. 2 times log of 2 plus square root of 5 plus log of square root of 2 minus 1 minus 5 plus 2 minus square root of 5 plus square root of 2. Only thing is you check the multiple choice options. The options are in single logarithm, so these two you can combine actually. Okay, so this will become log of 9 plus 4 root 5 into square root of 2 minus 1 minus square root of 5 plus square root of 2, or you can also call this in this form. You're right. Okay, so this is the answer. Now let's solve this the same problem using sine hyperinverse function. Okay, and see whichever is easy you can follow it. Next. Yeah, let's do the same problem using sine hyperbolic inverse. Okay, the value of integration of minus 1 from minus 1 to 2 of log of x plus square root of x square plus 1 dx is equal to. Okay, we know that this log is nothing but sine hyperbolic inverse. Okay, inverse of sine hyperbolic function. Okay, so which means the integration is nothing but integration from minus 1 to 2 of sine hyperbolic inverse of x dx. Okay, now you consider product rule. This is your f of x, g of x is 1. Okay, so this will become, okay, before that, since this sine hyperbolic function is an odd function, we can remove some of the limits actually. Okay, especially from when the limits are from minus 1 to 1, this is the odd function. Sine hyperbolic inverse is the odd function, this will become 0. Okay, so which means integration is nothing but integration from 1 to 2 of sine hyperbolic inverse of x dx. Okay, now you apply the product rule. Okay, so this is my f of x, so g of x is 1. Okay, so integration of g of x, that is the integration of 1 is x into sine hyperbolic inverse of x minus integration from 1 to 2 of differentiation of sine hyperbolic, which is 1 by square root of x square plus 1 into integration of 1, which is x, okay, dx. Okay, now you apply limits to this one. If you apply limits to this one, this will become 2 sine hyperbolic inverse, sorry, this is inverse of 2 minus sine hyperbolic inverse of 1 minus integration from 1 to 2 of x by square root of x square plus 1 dx. This is simple. We know we take x square plus 1 as t, you will get x dx as dt by 2. So with that you can solve it. And this one is sine hyperbolic. You should remember value sine hyperbolic inverse 2 is log of 2 plus square root of 5. Okay, and sine hyperbolic inverse of 1 is log of 1 plus square root of 2. Correct, that is what here. If you see, if I substitute 2 here, this will become log of 2 plus square root of 5. If I substitute 1, log of 1 plus square root of, okay, that's what is here. So this integration is now reduces to 2 log 2 plus square root of 5 minus log 1 plus square root of 2 minus I2. Now my I2 is, I can I solved it again previously also. You take x square plus 1 as t, and then 2x dx is dt. So with that you can solve it. So this is nothing but half of 2 times square root of x square plus 1. If I apply limits, this is square root of 5 minus square root of 2. Now my whole integration is nothing but this value. You combine these logs and same answer as before. Okay, so you can decide which one is easy. Okay, sine hyperbolic you want to take, because this is a straightforward sine hyperbolic definition, right? So yeah, if you remember, you can solve it using this method also. Both are easy. Okay, you should know. Next, the value of k, which is a natural number for which the integral in is equal to integration from 0 to 1 of 1 minus x power k whole to the power of n dx, where n is a natural number, satisfies 147 I20 equal to 148 I21. Okay, so this is one very important problem. This is where I want to introduce this beta function actually, and more in the next problem. Okay, so this is what is given, 147 I20 equal to 148 I20. So if I take 147 common, 147 into I20 minus I21 equal to I21. Okay, now all I need is I20 minus I21. What is this? Okay, integration from 0 to 1 of 1 minus x power k whole to the power of 20 minus, if I combine these integrations, minus 1 minus x power k whole to the power of 21. If I take this as common, correct, if I take 1 minus x power k whole to the power of 20 as common, I am left with 1 here, and here I am left with 1 minus x power k, since it is a minus sign here, minus, if I apply, minus 1 plus x to the power of k. Now I am left with simple integration. I20 minus I21 is nothing but integration from 0 to 1 of 1 minus x power k whole to the power of 20 into x to the power of k dx. Remember this. Okay, now next we will go next step. Okay, I21. Okay, what is I21 value? Okay, because this is equal to I21. Now we found some value for this one. I21 also will express in these terms basically. Okay, So how do you do that? I21 is nothing but integration from 0 to 1 of 1 minus x power k to the power of 21 dx. Okay. Integration by product rule. Take this as f of x and 1 as g of x. Okay. So this will become I21 is nothing but 1 minus x to the power of k to the power of 21 into x integration of g of x, that is. Okay. Minus integration from 0 to 1 of, okay, differentiation of this one, 21 times 1 minus x power k to the power of 20 into differentiation of this one is nothing but minus k x to the power of k minus 1 into integration of g of x, which is x. Okay. Now here, if you see here, if I apply the limit 0 to 1, this will become 0. Okay. So my integration I21 is very simple now, only this part. And if I take minus and minus 21k common, that is plus 21k, integration from 0 to 1 of 1 minus x power k whole to the power of 20 into x to the power of k dx. Correct. This is 21k into, this is nothing but we actually derived, right? This is the value. Correct. This is nothing but I20 minus I21. Okay. Now actually this is what is beta function. Okay. So we'll do in the next slide more. Okay. Now my, if I combine all these bold derivations, okay, 147 into I20 minus I21 equal to, which is I21, that is nothing but 21k times I20 minus I21. So these two gets cancelled on both sides. I am left with 147 equal to 21k. Correct. That is k is equal to 147 by 21, which is 7. That's the answer. Okay. So here we didn't use the beta function as such. Okay. We solved the problem without beta function, but this is complicated. Correct. So you should remember that there is a formula for this one. This is the beta function basically. Okay. This is nothing but beta of 19, sorry, k minus 1 comma 19. Okay. So I'll explain that in the next slides. Okay. So same problem I'm solving using a beta function. Okay. So use the beta function. Beta of m comma n is defined as integration from 0 to 1 of x to the power of m minus 1 into 1 minus x to the power of n minus 1 dx. Okay. Only thing missing in this is there is no x to the power of m minus 1 term. So this is not exactly the beta function. Correct. Beta function is when you subtract you got. Correct. So same thing. So if I take this, this is my I of n. Okay. I need to convert this into beta function, which is nothing but 1 by k into beta of 1 by k comma n plus 1. How this has come? Because this is the basic definition of beta function. Now you need to remember this as one more formula. Okay. Instead, you can actually get to this formula very easily. Let's do it here. I of n is nothing but integration from 0 to 1 of 1 minus x to the power of k whole to the power of n dx. Okay. Now I'll apply the product rule. Okay. Sorry, not product rule. I'll take x to the power of k as 1, k as t, which means k times x to the power of k minus 1 dx is dt. Okay. So my integration becomes integration from 0 to 1 of, okay, this is nothing but 1 minus t whole to the power of n, and dx is nothing but dt by k into x to the power of k minus 1. And x to the power of k minus 1, I can write it as t to the power of 1 by k minus 1. Okay. T to the power of 1 by k. X is nothing but t to the power of 1 by k. And x to the power of k minus 1 is nothing but t to the power of 1 by k minus 1. Okay. So with this, this will become, integration will become 1 by k. If I take out 1 by k, integration from 0 to 1 of 1 minus t to the power of n into t to the power of 1 minus k minus 1. Now you look at this. This is a beta function. Correct. This is the beta function where your m minus 1 is same as 1 by k minus 1 and your n minus 1 is equal to n. Correct. So this is nothing but beta of 1 by k comma n plus 1. 1 by k comma n plus 1. Okay. Now this is the beta function of this one. Right. This is what we derived. Okay. Now look at the problem now. Once you know this is very simple. This is nothing but beta of, and one more thing you remember, this you can derive very easily when I explain what is beta actually. Beta m comma n is nothing but n minus 1 factorial into n minus 1 factorial divided by m plus 1 minus 1 factorial. I'll explain in the next slide anyway. But this is what, with that you can easily derive beta of m comma n plus 1 divided by beta of m comma n is nothing but n by m plus 1. Okay. So now 147 I20 by 148 I21 is nothing but 147 beta of 1 by k comma 21, 148 beta of 1 by k comma 22. Okay, now this is nothing but I apply this one, so 147 by 148 will become 21 by 1 by k plus 21, which means 7 times 1 by k plus 21 is 148, or you solve it, you will get k equal to 7. Okay, so this is the advantage of beta function. Once you know this beta function, basically, so all this is in your memory, right? This is all in your memory. This is what you apply actually, and this probably you can derive very easily when I explain what is beta function actually. Okay, I'll explain in the next slide, because similar problem came in JEE one more, but very easy. There they defined what is beta function and gave the problem. Okay, so let's do that. So it is given next one more problem. This is in a different session in 2024 mains actually. Okay, here they gave beta function already. Beta m comma n is nothing but integration from 0 to 1 of x to the power of m minus 1, 1 minus x to the power of n minus 1 dx, where m comma n are positive. If integration from 0 to 1 of 1 by 1 minus x power 10 to the power of 20 dx is a times beta b comma c, then what is this one? Okay, this is what we derived just in the previous question actually, right? This is what, this is 1 by k beta 1 by k comma n plus 1, correct? So if I actually apply here, this will become 1 by k is 1 by 10 comma beta of 1 by 10 comma 21, right? So my a is 1 by 10, b is 1 by 10, this is 21. As simple as that. Problem is done basically. Okay, you get the answer ABC, you got it already. Okay, so if you know the beta of this one, this is very easy, but otherwise you can derive. We derived previously also, right? So I of n is nothing but 0 to 1 of, not I of n, this is I of 20, I would say. Okay, 1 minus x to the power of 10 whole to the power of 20. Okay, take x to the power of 10 as t, then 10 times x to the power of 9 dx is dt. Limits remain same, basically 0 to 1 is same because this is x to the power of 10 only. So integration will become 0 to 1, 1 minus t to the power of 20 into t to the power of 1 by 10 minus 1, correct? What I require is x to the power of 9, 1 by x to the power of 9, which is 1 by 10 minus 1. Okay, dt by 10. This is nothing but 1 by 10 integration from 0 to 1 of 1 minus t whole to the power of 20 and t to the power of 1 by 10 minus 1. Now this is in the same form, correct? Beta form. So now you take the beta. What is the beta of this one? This is nothing but 1 by 10 of beta of 1 by 10 comma 21. That's what I was telling. If you remember beta function, straightforward you can write this ABC values. Okay, this is what a times beta of b comma c. Okay, so a is 1 by 10, b is 1 by 10, c is 21. So my 100 times a plus b plus c is nothing but 2120. This is the answer. Okay, so hope you understand this beta function. Now let's understand the definition of beta function. Actually, we did not define what is beta function. We said this is beta. But what is that beta? We didn't tell actually, right? So the beta is actually, beta is defined as beta m comma n is nothing but tau of m into tau of n divided by tau of m plus n, which is nothing but m minus 1 factorial into n minus 1 factorial divided by m plus n minus 1 factorial. Okay, basically tau you take, whenever you take tau, it is factorial of one less number than what is the parameter. Okay, if it is x minus 1 factorial, if it is y minus 1 factorial, if it's 20, it is 19 factorial, like that. Okay, so this is what we used actually in the previous question. Let me go back. This one, beta m comma n plus 1 divided by beta m comma n, right? This is nothing but m factorial, both betas have, so gets cancelled. Okay, this will become n factorial divided by n minus 1 factorial, so I'm left with n. Okay, and on the denominator, first denominator of this one, I'm with m plus n factorial, and here m plus n minus 1 factorial, so I'm left with m plus n. So hope you understand how this beta division has come. Okay, so with that, I hope I explained the beta function clearly, and as of now these problems don't require actually definition of beta in mains, at least I have seen, but you should know the beta function. Whereas I'm sure in advanced, I'm not making in advanced videos actually, but in advanced I'm sure you should remember this beta function. Okay, so better remember it, do few problems based on this beta. Okay, yeah, this is really for advanced concept, this definition. Okay, Yeah, thank you. These are the problems PYQs I covered in this video. Keep checking my videos. I have playlist for all the JEE problems. Probably only probability is left actually. I'll do that as soon as possible. Okay. Keep doing maths until then. Thank you.